Hi, the new section today is Chapter 3, Section 2. It's the graph of y equals mx plus b, something you've been graphing for years, but have a nice way to do it. We'll come up with Roman numeral 2. But first, slope and parallel lines is Roman numeral 1. And if you wanted to, you could draw a graph and quick put a line on it. I'm not sure that's entirely necessary. But the book makes 2 points that I want to comment on. The first point is they say the slope everywhere on a straight line, or really I should just say it's 11 o'clock, there's my cuckoo clock. But slope everywhere on a line is the same. And if you were to take and look at some points, so I drew a line on there, right there's a point, there's a point. So if slope is rise over run, it rises 2, goes over 1, so the slope would be 2 over 1 or 2. And that should be the same for any spot on the line. If I look right there and right there, we go through a couple nice points. Rise is 2, run is 1, so the slope is 2. So that's supposed to try to quasi-prove that. If I were to then go back and take my line, the other point that they make is that if you have parallel lines, the parallel lines are going to have the same slope. And if you look, they're parallel, and when this goes up 2 and over 1, this one also then is going to go up 2 and over 1. So then the second comment then in Roman numeral 1, parallel lines have the same slope. Those are two things that are probably fairly intuitive. I don't know if you've thought about it, but they most likely make sense now that we've talked about it. Moving on to Roman numeral 2. Roman numeral 2 is how to graph y equals mx plus b. I'm calling it graphing y equals mx plus b easily. And first is we have to look at what's in there, and m is the slope, which is going to be rise over run, or change in y values divided by change in x values. And b is the y-intercept, or it's going to be what's the y value when x is 0. Because when x is 0, any number times 0 is 0. You just end up with y equals b once mx drops out. So to graph those things, I'd encourage you first of all to start with that y-intercept and put a dot at the y-intercept. Then 2, use the slope to find more points. So use the slope to find more points. I've noticed on quizzes and tests where people often lose points is this part right here. That really mean find more points, don't just find one more. Especially if the slope is small, like 2, like I had before. If you have a dot on your y-intercept, you go up 2 over 1, connect those with a straight line. Even if you're using a ruler, often you're not quite through the dots and you're off by the end of the graph. So people kind of get nickeled and dimed for accuracy there. And then number 3, carefully draw a neat straight line through the points. So draw a good line, maybe I'll say that, make it shorter. But neat and straight would be wonderful. Draw a good line through the points. And if you want to, these are kind of like my encouraged steps, but you could go back to making the x and y chart. You could even use your graphing calculator, put it in, and have that do a table for you. You could find x and y values. I don't know if that's noteworthy, but I figure I better cover my bases. The old way does work, but this really is pretty slick. 3 examples, then we're done for today. So Roman numeral 3 is examples, and I have 3 graphs on there. And my first example then is, what do I have? Y equals 2/3 x plus 1. So y equals 2/3 x plus 1. And what I was encouraging you to do is start out with that plus 1. So the y-intercept is 1, positive 1. So my graph should cross the y-axis right there. Now my slope is 2/3, which is rise over run. And both 2 and 3 are positive, so the 2 means you go up 2, then the 3 means you go horizontally 3. And you'd go 3 to the right because that's where your positive x values are. Get a couple more points, up 2 over 3. Now 2/3 is the same as negative 2 over negative 3. So you could look at it as though you go down 2 and then back 3. If that doesn't make any sense, then just look at what would you do to get one of those points you had back to the point before it. You get down 2, back 3. So you find a whole bunch of points. And then from there, let's connect those things. So start there, draw my line. I can kind of cheat a little bit with my thing here as far as getting a nice line. Something that you can use, your graphing calculator has a nice function. I call it the straight edge function. If you don't have a ruler handy, you can often use the edge of your calculator to make a decent line. On a quiz or test, I have the rulers. You're more than welcome to use those. That probably would be smart. But that's our first one. A second example. Switch colors to shake things up a little bit. This one then I have y equals negative 2x plus 3. And I'd encourage you to actually pay attention through all the examples, because I tried coming up with what are some things that mess people up. But y equals negative 2x plus 3. And two things in here kind of trip up some people. One is going to be the negative, but more often it's how do you do rise over run when you don't have a fraction. But let's back up. So first step is put a dot in your y-intercept. That's a positive 3. So my y-intercept is going to be right there, up 3 on the y-axis. And now our negative 2, if that's rise over run, it makes sense that negative 2 would be the rise. We're going to go down 2 to that point. But what do we do with the run? And negative 2, if you had to put it over a number, you could put it over 1. So essentially slope of negative 2 means you go down 2 and over 1. That spot there, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And really it goes quite fast for actually getting those points. So it's not too much of a time commitment to do that. But then you take and connect those points into a nice straight line, and voila, you're done. Last example, we'll go to, I have my equation being y equals 3x minus 4. So y equals 3x minus 4. And with this, the y-intercept is the point I wanted to make out. Since it's in that form of y equals mx plus b, if you go back to algebra class, subtracting is the same as adding a negative. So b is really going to be negative 4. So you have to count down 4 to get your y-intercept. And now the slope again, you could put the number over 1. So the rise would be 3 over a run of 1. So up 3 over 1, up 3 over 1, up 3 over 1. Then you're out of graph there, down 3, back 1. I'd encourage you, if I give you graph paper like this on a quiz, please, 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 don't start adding lines above it. Kind of do as much as you can in the graph that's there, and then be done. Also, to do a graph nicely, your graph really should go to the edge. Your line, whatever you're drawing on the graph, should go to the edge of the graph. So please don't give me this tiny little line in the middle of it. It'd be like taking a picture of somebody's cheek and saying you took a picture of them. You really should show the whole line. That is it for the notes from section 2.